I didn't have time. Okay. I'm gonna do the lunch thing. Where's that at?
Same room.
What room?
Mrs. Mitchell's.
Oh, okay.
Oh,
Yeah,
never
I'll
mind,
do
Lexi,
it.
I have them.
All right. We got a lot to do today. So we're gonna finish up the 6-4 notes, which kind of introduces us to 6-5. So then we're gonna go to 6-5-2 and see how much we can get done. Okay?
No.
So I need everybody's focus, and I need everybody to pay attention. I guess that's all I have to say. Remember, tomorrow's a day off, so let's grind today.
Oh, yeah.
And
That's
you
what
guys
I'm
have a day
doing.
off tomorrow. And you have a snow day this week, so we're ready to work.
That's what I'm doing tomorrow.
Guess what I'm doing tomorrow?
German food.
All right. I get my wisdom teeth out.
So we've been talking about nth roots.
Nth
roots. And when I say nth root, I mean any number root. And what we talked about yesterday was that if we can get the exponent underneath that root to match, they just cancel each other out because they're inverse operations, right? Like the 7th root of 5 to the 7th just undoes that power of 7, the 7th root, and we'd be left with 5. All right, so this is what we like kind of briefly started talking about. The thing that was weird about this one was when I broke it up, I didn't have like perfect 4 powers because 2 to the 4th is only 16. But I have a 32. So I'm like, okay, well, I do have a perfect 4th power there, but I do have this other 2 kind of left over because 16 times 2 would give me that 32. But I want to try to write it with as many like perfect 4th powers as I can, so I can kind of get like 1 perfect 4th power out of 32, which is 16. Same with the x. If I have 5 factors of x, how many perfect 4th powers or like groups of 4 could I get out? I could do 1, x to the 4th. But then I have 1 kind of left over underneath the radical because I have a total of 5. Does that make sense? Mm-hmm. Okay, so you're kind of breaking it up. And the ones I think in this lesson, for the most part, always come out to like a nice, clean answer. But then when we get to 6-5, you will see ones where there's kind of some stuff left over. So what happens here is this 4th root and this 4th power undo each other, and both that first factor and that third. So I would have a 2, and I would have an x that come out in front of the radical. Radical is this symbol. And then what's essentially like kind of left inside the 4th root is that other factor of 2 from the 32, and that other factor of x from the x to the 5th. Does that make sense? Mm-hmm. Okay, that's how we got there. So that would be the final answer. All right, that's what we started talking about yesterday. Now we're just going to basically do a bunch of examples because that's pretty much the best way to show you guys this. And then we have to keep in mind that little warning. If we ever take an even root of an even exponent and we get out an odd exponent, we got to wrap it with a hug absolute value bars. Okay, that comes up too later. All right, let's start off with some where that doesn't happen. Now remember, there can be symbols out in front, and that's fine. Those essentially just kind of like carry down in your answer. So here, let's start with the square root, something easy. So I'm trying to break up what's my radicand, and that means the number underneath. Radicand to as many as perfect squares as I can. So that plus or minus just kind of drops down. So the square root of 16, I know you guys know that's 4. I'm just going to practice writing it like this as 4 squared because when the roots get bigger, it might be a little bit more confusing. So that's 4 squared. And then y to the 4th. How could I write that as a perfect square? Y squared squared. Good job. Y squared squared. Everybody agree that that's the same as y to the 4th?
I agree.
Okay, now the reason I'm writing it like this is because you can kind of see what cancels out. So this square root would cancel out with this squaring. This square root would cancel out with this squaring. Okay, not this one. This one. So I end up getting plus or minus 4y squared for that.
4y squared.
Do you have a question, Will?
No.
Oh, okay. All right, let's try a 5th root.
Oh boy.
Does anybody know what number to the power 5 gives me 243? It is 3. Good. If you didn't know this, you would just start by guessing. Do 2 to the power 5 in your calculator. going to give you 32, right?
2 to the
Or is it
crap. Power
2 to
of
the power 5? Yeah, 32.
32.
3 to the power 5?
243.
243. So I could rewrite 243 as 3 to the 5th. You don't really need to put parentheses around the 3. You can if you want to. I'm not going to. 3 to the 5th. And again, I like to see it this way because then I can easily do my little fun canceling out satisfying step here if I can rewrite this as a power 5. We will look at examples when they're not perfect fifth powers, okay? But don't worry about that for now. What about a to the 20th?
A to the 4th to the 5th.
Okay, how'd you know that?
Because I guessed.
No, you didn't. Stop it.
No, because 4 times 5 is 20.
Yeah, 4 times 5 is 20. So essentially, guys, just take this power and divide it by your index. What's 20 divided by 5?
4.
4. And you're basically like reversing the power to a power property, right? That those would just be multiplied. Okay, so what about b to the 25th?
B to the 5th to the 5th.
Good job, guys.
Good job,
Down
Brayden.
here. Okay, so that would be b to the 5th to the 5th. Okay, now's the fun part. Once you get everything written as the matching powers with the index, these cancel, these cancel, these cancel. I would be left with
3A, 4B, 5.
3, a to the 4th, b to the 5th. Good job. All right, now I want you to pay special attention that was an odd index, so we didn't have to worry about any of the absolute value bars. Yeah, I'm just hinting at something we're going to come to later. Okay, ooh, this one's a little trickier. Let me show you what you can't do. Don't write this down. You can't split it up like this. You can't do that.
No,
Okay.
because there's parentheses.
Exactly. So really we're trying to think of how we could write this as a perfect square. So that's really, if I do 8 divided by 2 in my head, I could rewrite this as a power of 4, and that's being squared.
How do you power of 4?
Because
Watch.
8 divided
Oh.
by 2.
And then that would be the same thing as 8. I'm like reversing essentially the power to a power property. And I said an easy way to always do that if you don't know quite, take this exponent divided by the index. 8 divided by 2 is 4. And then I'm like, oh yeah, 4 to the 2nd. That would give me my radicand. Does that make sense, everybody?
Radicand. That's the...
Radicand is the whatever's underneath the radical. Yes, sir.
On the homework, do you have to show like the work that you just did number 2 and like number 3?
Honestly, if you can see the pattern, no, you don't have to. Good question. All right, so what cancels here?
the square root and
The square root and the square, and I would be left with x squared minus 6 to the 4th, and then that negative outside would carry down. That would be my final answer.
Sorry.
And guess what? You don't have to multiply it out. You can just leave it like that. Ooh, what if I have a negative under a square root?
Ooh,
I-
you get
We're gonna get an I. Okay, good. Let's break this one up. So 36 I could rewrite as 6 squared, and then times the square root of negative 1, that's going to give me the I. So that's how I could break up negative 36.
times
Okay, what about these variables?
x squared.
X
Y.
squared squared? Good. Y to the 4th? Yes, that would match these powers. 2 times 2 is 4. 4 times 2 is 8. Here's the fun part. Cancel, cancel, cancel. I would be left with 6. The square root of negative 1 is I.
6.
X squared, y to the 4th. Okay, does anybody have questions? It's about to get just a little more challenging. All right, here's your warning.
Warning.
Now, because anytime I do like a square root or an even root, so like a 4th root, 6th root, 8th root, we can only get out positive answers. Okay? So with variables, if I go back to that warm up, with variables, these do still undo each other. But if I get out something that has an odd power, such as x to the 1st, because I can get negative numbers out of there, I have to ensure that my output's only positive by putting in absolute values. So here's the rule. So here's where my warning came back right here. When you take the even root of an exponent that's even and the answer comes out odd power, odd exponent, then you need to put the absolute value bars in. Okay, I'll walk you through one of these, but I would say even, odd. It's like a little saying to remember that. Even, odd, absolute values. So let's take a look at one of these as an example. So again, you only have to worry about this with even roots, because with odd roots, we can have negatives that come out. Okay? Let's see if it comes up here in this example. All right. Ooh, 729.
3.
What to the power of 6 gives me 729?
3.
Why do you try so much?
It is
It's literally just put.
3.
Connor, step on a Lego.
Wow.
Oh wow.
That's mean.
Use your calculator faster.
No.
Sure, Michael could do it all.
Okay.
I love you, Michael.
Ooh, look at Y. Y is already written as a perfect 6th power.
Yes.
That's nice.
Yes.
I'm gonna actually change my. Sorry, I'm gonna change my.
What
No,
do
you're
you
good.
do?
You're good. I'm just gonna zoom in so I can
Now
write
you're
small.
confusing me.
I'm gonna do the same thing. I'm just rewriting it.
Calm down.
I'm a perfectionist. Okay. How could I rewrite X with the power of 6?
3.
3. Why?
Because 3 times 6 is 18.
Okay, are you good with that?
What?
3 times 6, that'd give me that 18. Okay. Y is already written as a power of 6. Nice.
Nice.
2 6.
Z would be 2. Good.
Oh, yeah.
Okay. So here's the fun part.
Wow.
Cancel, 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 cancel. I would be left with
3x cubed yz squared.
good. All right, now, since I took an even root, I have to look for this pattern. Did I ever do even, odd? And what I mean by that, even root, okay, check. It is an even root. Did I have an even exponent that I was 6th rooting? Yes, if I'm just looking at the x. Did my answer come out odd?
Yes.
Yeah.
Absolute value around that.
Okay.
Okay?
What?
Around the X?
Around the x, but I'm not done because let's look at y.
Okay.
Oh.
Even,
Five.
even root,
Even.
even,
Odd.
odd. Those both need to be in absolute value.
Wow.
Oh, what about z?
Well,
Wild.
z was even.
Oh.
Oh.
Wow, that's wild.
Math, baby.
Math?
Isn't
Pretty
3
nasty.
odd?
Yeah.
Yeah, that's why it needs to be in
Pretty
bars.
radical.
Even, odd.
The 3 is not
Pretty
odd.
lit.
That's for the exponents.
Oh,
pretty
only
lit.
for exponents?
Yes.
Okay.
Only for, this 3. I think I meant this 3. Yep. Only exponents. All the ones on the previous slide, I didn't give you ones where this example would have came up. Okay. So obviously, like this one's an odd root. These ones were even. This one was even. This one was even. So we didn't have to worry about it until now. Okay, so I haven't given you any examples yet. All right, let's try another one. Cube root, if it's an odd root, don't even have to worry about that rule. If it's an odd root, it can come out positive and it can come out negative.
All right.
So now I'm just trying to rewrite my radicand as a power of 3. So I could write this as y cubed plus 5 to the 6th to the 3rd.
To the 6. To the 3rd.
Everybody agree with that?
Yes.
Yep.
The cube root and the cube cancel. And I'm just left with y cubed plus 5 to the 6th. And again, I don't have to worry about that rule because I started with an odd root. All right, we only got 2 more, my friends. And then, ooh, fun. I get to show you how to do this in your calculator.
What?
All right, a 5th root. This is an odd root. So we don't have to worry about the even, odd.
Even
Okay.
odd.
Yes. 3 to the 5th
3 to the 5th.
is 243.
We already did that, didn't we?
Yeah, I think I gave you a repeat one. All right, could I write this with the power of 5?
No.
Yes.
Cubed. Good. Yep. 3 times 5 would give me 15. Or again, divided by your index. I'm warning you guys right now. I'm very picky about you writing in the index. Like if you forget to write the 5, I will take points off because then that's saying a square root. undoes a power of 5, which is not true. So just make sure you get in the habit of like writing in your index. Got it. I'm picky about that.
Cancel.
I'm so proud of you. Thank you, Connor.
Ooh, I see an even root, a square root. Even though there's no number in there, 2. It's really indivisible too. 2 is even, so I have to worry about my even, odd situation. All right, let's break this up. So square root of 81 would be 9 squared.
9 squared. A squared.
A to the 8th squared.
B to
Good.
the 10th squared.
B to the 10th. Wow, Willis is on his game.
C
C
squared.
squared. And that's already a perfect square. Now notice how these are all even. So if I get something out odd, it's going to need absolute value bars for exponents. Okay, these cancel.
These cancel.
Just repeat what I say.
Oh.
What needs a hug with absolute value bars?
Negative
Wait,
nine,
why did you
negative
get 3?
I don't know. I was squirting the 9, sorry.
Let's be nice.
I am being nice. C.
C needs absolute value
C.
because that came out odd. Even,
I
odd.
did that like 5 years ago.
What?
So.
Even,
I'm
no,
scared.
Connor, odd.
Got it.
And guys, do the A and the B need
No, because they're even.
even, because even if A or B are negative, if I raise it to an even power, it's going to come out positive. So just the even, odd. Okay, good. Now I'm going to show you how you guys can type in any number root into your calculator.
All right.
You click this button.
Carrot.
See,
Do you know how to do it?
for this
This is
button
Yes.
and
This is what I'm
71, and you get 2.9.
What's the deal with that?
You just put your number 5. This button.
Well, it says like if Carter runs CP, but I'm a waitress, so CP makes me think a cheeseburger.
2.9 out of
Cheeseburger.
I got
Cheeseburger.
negative 5.3.
Cheeseburger.
Oh,
They
what's
got
going
me
on
that
right now? I'm very confused.
4, 7, 5, 6 square.
All right, so obviously you all know where the square root button is, right?
It's on the calculator.
Yes, do you know where?
On the calculator.
Right here.
What?
Yeah.
Okay,
Seconds.
so if you want to do a 4th root, what you have to do is you have to first type the index, you type 4.
4. Then you put second
Wait.
and the button above
Do you
carrot.
press?
Oh,
Do you press
no,
4 or
you
do you
press
press
four.
second
Press
first?
You press 4 first,
Okay.
then you want to hit this button,
Do you want to press two?
which is
second?
right here. Yep, second, and then
Second
the up caret.
Mm.
And that's going to substitute
Someone has
the
a graphing calculator like you.
That's going to substitute the 4 into your index. All right, so if I want to do the 4 through to 71, then I would type in 71, and I would hit enter. Let me get this decimal, because 71 is not a perfect 4th power. Okay, so let's write that here. We get about 2.9027, dot, dot, dot.
Dot.
2.9.
Who?
Everybody okay with that?
Nice.
For now.
Yeah. 7, dot. Alright, I did this one.
Okay, try the next one. Try the 5th root
Negative 5, 3, 9, 7.
of negative 4,382. This is
5,
Negative
3,
8.1,
4, 9, 7,
Yeah, I
dot.
know. It should be.
Isn't it imaginary?
no, it's a 5th root.
Oh yeah, I forgot. That's
Fifth root.
Only for even roots.
Oh, you do imaginary?
You do imaginary, but we can
Why is
add
that?
roots because like we can like you can cube root a negative number because like what number cubed gives you negative 8, negative 2.
Yeah.
But there's no negative number that when I square it, I would get.
Yeah.
Okay. All right, let's see this. If you can type this one in, here's what I got.
11.2367. Dot.
This is correct.
Let's go.
Yeah.
James, just give it.
Oh, I put 4, 3, 8, 2.
Okay, make sure you know how to type this in your calculator. That's all we have for 6-4. That's
Yeah,
it.
we're done.
No, we're not.
Oh. Good thing we only have one. Good thing we only have one assignment though, right?